Hi everyone. So weekly video coming at you here. This one's going to be about the different types of nuclear decay and how to actually set up those chemical reactions that happen whenever you have one of these three types of decay. Mostly we're going to be focusing on alpha and beta because those are the ones that actually eject a subatomic particle that we can actually measure that has a reasonable mass. But to first get started off, all of these different types of decay, alpha decay, beta decay, gamma decay, are all types of what's called nuclear decay. And that's just a general catch-all term for the process by which you have your nucleus inside your atom. That's just the process by which it starts to emit the subatomic particles from itself. So it starts to eliminate or get rid of, I guess you could say lose, whichever one of the terms you like, protons, neutrons, and electrons. Those are three subatomic particles that we're going to be focusing on here as I teach you how to set these up. But let's first go ahead and talk about some qualities of these really quickly. You should have already read a small little article from Khan Academy about these, and I'm going to encourage you to go back and do that because I don't want to be the person to reinvent the wheel, right? I don't need to do that. I don't know why I did that, because they actually do have Greek letters. So the thing about alpha, I'm also going to, give it its actual Greek letter. We have alpha. This one is usually capital beta. So it's like a B with a tail. And then our gamma is kind of like a, good enough. Anyway, so alpha, I'm going to specifically talk about the particles that it emits, okay? So for alpha decay, this is the type of decay that is most massive, and what this gives off is a helium atom. Helium atoms are composed of 4 protons and neutrons, and they have 2 protons. So whenever you see the notation for alpha decay, it's going to look like this. So you can have something like, let's see, alpha decay happens in mostly very large elements, so I'm going to try and think of a large element right off the top of my head here to figure out which one I should do. I'll do a really common one, actually. I'll do what's common, whoopsie, for us to encounter whenever we're talking about nuclear energy. And that's going to be our uranium-238. So, you'll start off with something off to the left here. This 238 represents the atomic mass of my element, and your atomic number of your element would go right here, okay? And so if we look up our atomic mass for this element, so hint, hint, it might be useful to have a periodic table around if you don't have one at home, which, I don't even have one at home unless it's on a t-shirt. ptable.com is probably my favorite one. It's really easy to use and shows you everything color-coded. So, if I go to the bottom of the periodic table in the actinide series, I see uranium, and I see that its atomic number is 92. Okay? And if this undergoes alpha decay, that means that it lost 4 from its atomic mass. So I have 234 up there because 4 plus 234 is 238. And I'll have an atomic number of 90 because 90 plus 2 is 92. Now, then I would have to go see which element number 90 is, and I see that it's thorium. So this is the correct balanced nuclear decay equation for alpha decay. Now let's go ahead and look over at beta decay, okay? Beta decay is going to have a less massive give off of subatomic particles. what's going to happen here is that we're going to be giving off an electron. So we're going to scroll up here. So it emits an electron. And so it reduces atomic number by 1. Okay, so I could have an example here like, what's one I know? Let's go ahead and let's do potassium. Why not? So potassium is element number 19, and it has an atomic mass of 39. And based on my knowledge of just how elements work, I know that I have the same number of protons as I do electrons. So 19 is my number of electrons. So if I have a beta decay situation, I'm going to have a -1 here because that represents the charge on that electron, and it does not contribute to the atomic mass, right? Because the only things that contribute to atomic mass are protons and neutrons. So all I have to do is figure out what some number -1 is 19, right? So that's going to be 20. And so you just go 1 over to the right. It's calcium. Easy peasy. Now, gamma decay goes even further in emitting pretty much a massless subatomic particle. These emit photons. And as you should have read in that Khan Academy article, you'll notice that they're pretty much the highest form of energy as far as nuclear decay goes. Basically, you can block alpha decay with a piece of paper, right? There have been experiments doing that. So really, the only calculations that we're going to be doing are going to be those for alpha and for beta decay. So they're going to be like these right here. So you may want to get these down on a piece of paper, right? Okay. And I'll do a couple more. That way you're able to see the different types of problems that you might encounter on the assignment whenever you're trying to go in and do it. Okay, coming back with some examples here. I've got a beta decay situation right here, and you can tell it's beta decay because I've used my beta Greek letter, right? So it can be this, or the electron symbol. Interchangeable, does the same thing. So we're going to do the exact same thing as we did before with our beta decay problem, where we figure out what element goes right here. So we see that our atomic mass is not going to change, because 0 plus 115 will equal 115. So now we need to figure out -1 plus something equals 47, and that's going to be 48. And if we just go and take a look at the periodic table, all we need to do is look at what's next to Ag, which is silver, and that's going to be cadmium, or Cd. Now there are actually rules as to what undergoes alpha, beta, gamma decay, all that. I'm not too concerned with them right now. Just helping you get the general process down. And let's say that we have, for our example of alpha decay, let's go with gadolinium. I did a lot of research in college with gadolinium, so it's one of my favorite elements. It's fluorescent under UV, which is really fun. Okay, so let's say this undergoes alpha decay, okay? This is the 4 and the 2, and I can write alpha, or I can write He, because all it is a helium nucleus, right? Atomic number of 2 is helium. But I'm going to write it like this. Okay? So all I need to figure out is 2 plus whatever is equal to 64. That's 62. 4 plus whatever is 157. So it's 153. Now all you need to do is just go and figure out what number 62 is, and that's samarium, which has the symbol Sm. Alright, so those are your examples. You only have a few of these types of problems on your assignment for the week. The rest are just going to be definition based, or they're going to be based around like reflecting on the differences between different types of nuclear decay or nuclear reactions, things like that. So hope this helped, and feel free to reach out if you need any more help.